Decoding the Vision of Bitcoin, How Satoshi Nakamoto's White Paper Revolutionized Digital Currency. The Bitcoin White Paper begins with a succinct abstract that encapsulates the essence of the proposed digital currency system. It presents Bitcoin as a purely peer-to-peer version of electronic cash, allowing online payments to be sent directly from one party to another without going through a financial institution. The problem Bitcoin aims to solve is twofold. First, it addresses the issue of trust in financial transactions, traditionally facilitated by a central authority. Second, it seeks to eliminate the possibility of double spending, a significant challenge for previous digital currencies. The introduction further elaborates on the decentralized approach, which is the cornerstone of Bitcoin's design. By leveraging a distributed ledger, known as the blockchain, Bitcoin operates on a consensus network that is powered by its users, thus eliminating the need for a central authority and democratizing the flow of digital value. In the realm of Bitcoin, transactions are conducted on a peer-to-peer basis, eliminating the need for intermediaries such as banks. This system allows for direct financial exchanges between individuals, no matter where they are located globally. Each transaction is a digital exchange of Bitcoin, verified by network nodes and recorded on the blockchain. As for privacy, Bitcoin achieves this by dissociating personal identity from transactions. Instead of using personal data, Bitcoin utilizes cryptographic public keys to represent users on the network. These public keys serve as pseudonyms, concealing the true identity of the participants while allowing their transaction history to be publicly traceable on the blockchain. This innovative approach maintains a level of transparency for transaction verification while upholding the privacy of individuals' financial activities. The Bitcoin network incorporates a timestamp server as a fundamental component to enhance the integrity and chronological order of transactions. This server takes a hash of a block of items to be timestamped and widely publishes the hash, such as in a newspaper or Usenet post. Each timestamp includes the previous timestamp in its hash, forming a chain, with each additional timestamp reinforcing the ones before it. This immutable sequence is critical for preventing double spending, as it establishes the exact order of transactions, ensuring that each coin has a clear history. Understanding the proof-of-work mechanism is crucial to grasping how Bitcoin maintains security and consensus. Proof-of-work involves solving a computationally difficult puzzle to create a new block, which is then added to the blockchain. This process, known as mining, requires substantial computational power and acts as a deterrent to malicious activity. To alter a block, an attacker would need to redo the proof of work for that block and all subsequent blocks, which is practically infeasible. The proof of work system is instrumental in combating double spending, a vulnerability where a single digital token can be spent more than once. It achieves this by ensuring that network participants agree on a single history of the order in which transactions were received. The longest chain not only serves as proof of the sequence of events witnessed, but as proof that it came from the largest pool of CPU power. As long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. This elegant synergy between the timestamp server and proof of work secures Bitcoin's ledger against fraudulent transactions and maintains the integrity of the currency. The Bitcoin network achieves consensus through a distributed system where each node or participant holds a copy of the blockchain. This decentralized approach ensures that all transactions are verified and agreed upon by the network through a process called mining. Miners, who are nodes in the network, validate transactions and are responsible for adding new blocks to the blockchain. In return for their computational work, miners are rewarded with newly minted bitcoins, known as the block reward, as well as transaction fees from the transactions included in the new block. This incentive system secures the network by encouraging a large number of miners to contribute their computing power, which in turn increases the difficulty and cost of potential attacks. The mining rewards serve a dual purpose. They create an economic motivation for miners to maintain the network's operation, and they gradually introduce new bitcoins into the system, mimicking the extraction of precious resources from the ground. As a result, mining rewards are essential for the stability and security of the Bitcoin network, ensuring its integrity and the ongoing validation of transactions. Simplified Payment Verification, SPV, is a method described in the Bitcoin Whitepaper that enables users to verify transactions without running a full network node. This approach is facilitated by lightweight clients, which download only the block headers of the blockchain rather than the entire block content. SPV clients can confirm that a transaction has been included in a block and subsequently appended to the blockchain without needing the full transaction history, thus significantly reducing the data burden. While SPV enhances convenience and accessibility for users with limited resources, it does introduce certain trade-offs in terms of security and privacy. By not maintaining a full copy of the blockchain, lightweight clients rely on full nodes for accurate transaction information, potentially exposing them to risks if connecting to dishonest nodes. Despite these trade-offs, SPV remains a popular choice for everyday Bitcoin transactions, striking a balance between efficiency and the trustless ethos of the Bitcoin network. The Bitcoin Whitepaper acknowledges the importance of privacy in financial transactions, suggesting that while the system is not perfectly anonymous, measures can be taken to increase privacy, such as using new addresses for each transaction. However, it also recognizes the limitations in scalability, given the need for every transaction to be broadcast to the network and recorded on the blockchain. As Bitcoin's adoption has grown, so too have concerns about its ability to scale effectively to handle a larger volume of transactions. Looking to the future, various solutions have been proposed and implemented to address these challenges. The development of second-layer protocols, such as the Lightning Network, aims to facilitate faster and more numerous transactions off the main blockchain, potentially alleviating congestion and scaling issues. Privacy enhancements are also an area of active research, with advancements like confidential transactions and other cryptographic techniques being explored to improve anonymity without compromising the network's security. These ongoing developments reflect the dynamic nature of Bitcoin and its community's commitment to evolving the network to meet growing demands while striving to enhance user privacy. In conclusion, the Bitcoin Whitepaper presents a transformative vision of a decentralized financial system where peer-to-peer transactions and cryptographic proof replace the need for trust and central authorities. Satoshi Nakamoto envisioned a future where financial sovereignty is restored to individuals, free from the constraints of traditional banking. Despite the evolution of technology and the emergence of countless other cryptocurrencies, the white paper remains a fundamental document, its principles still guiding the development of the Bitcoin network and inspiring ongoing discussions about the future of finance. HumansAreInCharge.com, prompted by a human, performed by machines.